Okay, hello everyone and welcome back. We're going to go and look at the exit ticket. This is Monday again, day 5. All right, the homework check video's in there and the warm-up video's in there. So now we're going to do a video on the exit ticket, call it up. All right, hopefully you guys are there again. You can always stop the video and you can look back on it if you want, okay? Anyway, generally speaking, as x approaches infinity, which of these functions grows the fastest? Let's take a look at them in Desmos. Here's the 3 functions right there, okay? The red one is linear. There's a slope of 2x. All right, the blue one is a quadratic, x squared. And the green one is the exponential, 2 raised to the power of x. All right, we'll look more at exponentials later, but we're comparing here. As you get real big, in fact, let's do this. Let's just scroll out and go big. As we get big up here, like by 100, which one gets the fastest up here? You see, linear is left behind. In the beginning, linear looks pretty good, but take a look at this, the green one. The green one, which is the exponential, right here, ends up going up the fastest, okay? We can back out again and see the green one goes up the fastest. But inside here, it's not like the first linear goes up the fastest in the first, so be aware of that when we're really close in here. All right. Oops. Let's go on to number 2. I think I switched to the doc cam now. Yes. Okay. All right, we're looking at the table now, which shows some of the values of 2 continuous functions. These are continuous based on any interval we look at. Which function always has a greater rate of change? Which is going up fastest all the time? All right, again, the interval, they mean the x. It's going up, x is always the same, because we're just using this x is for these 2, this 0 is for these, okay. All right, f of x goes up by 2, by 3, by 4. But g of x goes up by 4, 8, 16. G of x is going up faster. G of x is the rate of change is faster here. Faster here. For any interval you pick, g of x is going up faster, okay? This is kind of a weird problem, guys, I gotta admit. Which interval has the same average rate of change for each of these functions? Which interval? All right, which interval of x here? Now, the way to do this one is look at the linear first. This has a slope of 1. See, this rate of change is the same all the time. It has a slope of 1. So we're looking for these 2 where they have a slope of 1. What interval do these 2 have a slope of 1? I'm watching the Viking game here. It's 0-0 still. All right. Guys, it's this one right here, between 0 and 1. Right here, that says a slope of 1 right there. And the same with this one, 0, 1, slope of 1 right there. All right. See, between 1 and 2, this one goes up 1, 2, 3 over 1. This one goes up 3, that's the quadratic. And this one goes up 2, 1, 2 over 1. This one goes up 2. We're looking for where the rate of change is 1, so it equals this. Between 0 and 1, right here. Between 0 and 1, okay? All right, number 4. Again, the average rate of change for the interval. 1 or negative 1 and 2. Again, those are both x. That's not a point, xy. No, look at their square brackets. It's an interval. They're both the x. So first you plug in -1, where x is right here. That's a of -1. I plugged x in right there, and I got 1. All right, it's 2, or -2 plus 3. All right, then I put 2 in there. I put 2 right there, so 2 times 2 plus 3, that's 7. So those are our two x values. I'm sorry, those are our two y values. All right, the x, -1 and 2. So here's one point here, -1, 1. I put that point right here. Here's the other point, 2, 7. I put that point right here. Calculate the slope, and I got 2. All right, again, the average rate of change is the slope. That's what they want, the slope between 2 points. They give you the x, we have to calculate the y. All right, same formula we used before. All right, do the same thing with this one. So -1 and 2. So b of -1 and b of 2. So I plugged in -1 here. All we're doing is squaring it. Here I got 0. 4 minus 1, here I got 3. All right, so my one point is 0, -1. I put it right here. I'm sorry, -1, 0. I put it right here. The other point is 2, 3. I put it right here. The x on the bottom, the y on the top. This part goes on top. The interval is on the bottom, you see, for both. All right, I got -3 over -3. The answer was 1. I'm going to have to hustle here, guys, a little bit. All right, this is number 5. The interval is 2, 5. I plugged it in right here. It's just 2x plus 1, so 2, 2 plus 1. 2, 5 plus 1. I got 5 and 11. Again, here's the slope formula. Because these are 2 points now, you've got them. I got a slope of 2. Right? For b here, it's x squared plus 2, so I squared 2 and I squared 5. And I added 2 to both, and I got 6 and 27. All right, the difference in the y's, the difference in the x's, I got 7. All right, for number 6, again, the rate of change between this interval, -1 and 2, that's the x. So I'm using -1 right there and 2 right there. And they give us the y values. Again, so you put one point, y2 minus y1. It doesn't matter which one you call. Just make sure that this is a point and that's the other point. Make sure that's what's going on, okay? Same with this one. -1 and 2. -1 and 2 are the x's. The corresponding y values is 1 and 7. That's what goes on top here. I ended up with 2 here. And you can stop the video. I just have to get going here and run out of time. Guys, the average rate of change for the interval 1 to 3. This one says this is number 8. This is number 8. All right, so 1 to 3. 1 to 3. So 1 is right there. 3 is right there. So let's count up. 1, 2, 3, 4, 5, 6 over 2. The answer is 3. This right here is a slope of 3. That's a slope of 3, okay? All right, number 9, interval between 1 and 3. So this is 1, and this is 3. All right, come down to right there is where the 1 is, and 3 is way up here. So count 1, 2, 3, 4, 5, 6, 7, 8. So 8's on top. That's the rise. 2 on the bottom. I got 4. Again, I made a triangle. You guys remember how we did this? That's the slope of this line right here between those 2 points. That's the average rate of change in this interval. It doesn't matter what happens but this could have gone like this. As long as it ends up right here, the average rate of change would be the same. All right, number 10. I'm right at the end here, guys. I've got to quit. Guys, the average rate of change for any interval. For any interval in this, that's a straight line. It's always 1. All right, but if you want to go 1 to 3, up 2 over 2, right, that's a slope of 1. So any interval, constant slope, okay? As I hope that helped you, I have to stop, okay? I plan to be back tomorrow.